So, yeah. Can you put up your hand if you are actually using Node.js in a serious production system? Look at that. Just look at this here, right? How many conferences have you been in where people have done this raise your hand thing and it's been like 10 people or 20? Do it again. Put up your hands again. Who's using Node in production? That is like everybody, right? Give me the next slide. So we won. We won. Everybody who said callback hell and JavaScript and event loops don't scale and all that stuff, they were wrong. They were dead wrong. We won. Node.js is used by a whole bunch of serious companies. And companies like IBM and Walmart, not just cool internet companies like Netflix and Uber, but really serious companies doing serious things. And we know that we won because Node.js is technically better. We know that actually JavaScript is not a weakness, it's a strength. We know that the event loop is not a weakness, it's a strength. We know that the module system is not a weakness, it is a strength. But you have to dig a little bit deeper. You have to ask another why, a deeper why. We know that the technical side of Node.js is really awesome. That's the reason we got into it originally, and that's the reason we are using it ourselves. But why did Node become so dominant when there are other systems that are also really, really good technically? It's not a case that naturally the technically best system wins. And there's lots of examples in history where a technically better system didn't win. So why has Node won? And I think that's an important question to ask because there's something deeper going on here. And give me okay, so this diagram is a schematic from a clock, an 18th century clock called the Harrison H4 clock. And this is kind of an example of how technology meets a need and the need drives technology in a really interesting feedback loop. In the 18th century, there was a really big technical problem with longitude. So navigating ships across the Atlantic was difficult. It was difficult to do accurately. You could measure latitude, how far north and south you were, quite accurately by measuring the angle of the midday sun using a sextant. People have been doing that for centuries. But measuring how far east and west you were was a very different problem because you had no fixed points of reference. And you could either spend hours doing tons of trigonometry from lunar observations, and highly capable mathematicians were in relatively short supply, especially ones that didn't want to die going on ships. So what you did was you used something called dead reckoning. This is where the term knots comes from. You have a rope, and you tie knots at regular intervals, and you have a log at the end of the rope, and you throw it over the back of the ship, and you wait 5 minutes, and you see how many knots go out the back of the ship. And that gives you speed, and with the heading and speed, you can kind of work out on a chart where you're going to go. But you can see that those errors are cumulative. And people were dying, ships were sinking, because they were ending up tens of miles from where they were supposed to be. There is a really simple solution, which is if you have an accurate clock, you set it to Greenwich Mean Time, and then you measure your local time, and of course, 1 hour is every 15 degrees, so it's really, really simple to tell where you were. And the British Parliament in 1714 set a prize, £20,000, which at the time was like 2 million, right? For anybody who could efficiently solve this technical problem. And a self-taught watchmaker called John Harrison built a series of clocks that solved the problem of accurately telling time on a ship. And if you think about it, it's a hard problem because the ship moves about all the time. You've got pressure changes, you've got salinity, you've got all sorts of really horrible stuff that mess with the delicate mechanism of a clock. And Harrison worked very hard to solve all of these problems one by one. So instead of using a pendulum, he used counterbalanced weights. He carefully compensated in terms of tolerances in the gearworks for all the different expansions and contractions and all that sort of stuff. And in 1761, the H4 clock, the design of which you see here, across the Atlantic and went from England to Jamaica and plotted the ship's course to within an accuracy of 1 nautical mile. So it was a technical triumph. Of course, he faced the same problems that we used to with Node, where the establishment and the entrenched interests blocked him for many years. But what he had done was he established a technically superior solution to an existing need. And because of that, you get a really nice feedback loop where the clocks become cheaper, and eventually you can do accurate navigation. And we are in a similar place with Node, because what's happening out there in the big bad world has affected the growth of Node. And there's a feedback loop going on between Node and this buzzword, digital transformation. And what it is essentially is old established companies suddenly realizing that just having a website or an app is not enough. It doesn't actually give you the full potential of building software systems, of being able to hook up all the pieces of data in your system and connect them all together in a really, really efficient way, and being able to deliver it fast. So instead of having 2-year projects, being able to do things in 2 months. The average Fortune 500 company has about 10,000 internal software applications. And most of them are built in a complete hodgepodge of languages, and most of them don't even talk to each other. Digital transformation is about suddenly saying, wait a sec, this is crazy. We need to have a unified vision of how we can use software to make ourselves better. And this is being driven by the examples of Amazon and Netflix, where people are seeing that if you focus on technology and you start thinking in terms of technology, you can move much faster as a company. And this is part of the reason why Node has taken off. Yes, it's technically brilliant, but there is a need. Just in the same way that in the 18th century, there was a need to navigate ships accurately, there is a need to move faster and build software faster. And Node came at the right time, was at the right place to fit into that need. So next slide. So my company, nearForm, we like Node technically, and we got into Node 3 or 4 years ago, and started building systems for startups, and then eventually started building these systems for big companies. And this talk is really a kind of observation of this trend and what's happened over the last couple of years, and why we think people have started to adopt Node, especially big companies have started to adopt Node, because it helps them make this transition. Next slide, please. So the reason it does that is because it lets you deliver value early, which is kind of a corporate speak way of saying you can build software very, very fast and you can iterate really, really quickly. And I like this. I like these little stone statues. I think they're a good metaphor for being able to do that. So these are 3,500 years old. They're from the Egyptian pharaoh Menkaura. And they're actually, this was basically found not in the tomb, but beside the tomb. So these are like unfinished pieces. But you can see from the statues that they didn't try to get the head right first and then work their way down the body. They iterated until they got to the final piece, so that if you made a mistake, you weren't going to throw away tons of work. And this is a great metaphor for what building software is actually like. Because if you think about it, time in a software project is like stone in sculpture. You never get it back. Once it's gone, it's gone. If you waste a week building a feature that nobody's ever going to use, that week is gone. You have to be able to iterate quickly. And Node lets you do that. And it lets you do that in a couple of important ways. And I'm just going to focus on a few of them so we can understand how Node fits into this digital transformation idea. So next slide, please. Possibly the most important one is the CEO's paycheck. So the whole idea with digital transformation is the CEO can think of some new initiative to increase profits or change the direction of the company. And we go to the old school IT departments and the old school software developers who are using Java and .NET, And these guys come back and say, this is going to take 18 months or 24 months or something like that, because we can only be on a quarterly release cycle. This doesn't work because what the CEO wants to do, what they're under pressure to do themselves, is build it in this quarter and deploy it in the next quarter and then get their bonus in the quarter after that. And if you can't build that fast, suddenly you're not in the right place. But we know that Node can. Next slide. The reason that we know that Node can is not because there's some deep explanation in and of itself. Our experiences over the last 4 years have simply shown that there is empirical data. There's just facts on the ground that when teams use Node, compared to the older classical OO languages, they're just faster. PayPal did the famous experiment 2 or 3 years ago where they put a Node team head-to-head with a Java team, and the Node team delivered twice as fast, validating Node as a technology choice. But we see this across the board in the projects that we do, and in lots of the people that we talk to. There is enough evidence, there is enough actual data on the ground, even if we have no explanation for it, that Node is faster. And that is an important point to remember. You have the weight of evidence behind you. Next, please. Another barrier that Node breaks down is due to its simplicity. So if you think about what motivated the original design of the object-oriented languages was the idea that you could model the world, that objects and classes were somehow a representation of the business challenges out there. But what always struck me was you have this object-oriented language that has all these features like inheritance and polymorphism and all that sort of stuff. And that turns out not to be enough. You also need to go and read the Gang of Four book, because there's also 30 design patterns that you have to use. So you have this complexity, and that's not enough, and you need another layer of complexity. And then the whole system ends up being swamped in this technical debt, because all these objects have all these interdependencies, and you end up with Spring and different approaches like that to try and manage it. And the problem is you have this inherently complex system that's too powerful and creates technical debt. Node, in a way, addresses that problem and makes it go away because of its simplicity. And again, there's evidence to support that. Node, because you have to write less code, means you have less bugs and less technical debt. Next slide, please. There is an interesting set of data to support that. And this is supporting the idea that there is a relatively fixed number of bugs per 1,000 lines of code, which is an interesting idea if you think about it. Independent of language, the number of bugs is directly proportional to the number of lines of code, and it doesn't matter what the language is. And I first came across this idea in a book called Code Complete by Steve McConnell, and he referenced a study that was done in the 70s. And it had always felt intuitively right to me, but there hadn't been much supporting data. But a company called Coverity that does static bug analysis, they have a static bug analysis tool, did do some research into this in the last couple of years. And they took 32 established open source projects. And the important thing is they were in different languages and they were of different sizes. So it was a very heterogeneous sample. And this is what they came up with. These are the number of bugs per 1,000 lines of code. And you can see the distribution is skewed, which you'd expect. And the mean is about 0.4 bugs per 1,000 lines of code. Now, bear in mind, these are established open source projects that have been around for a couple of years. What's interesting about this is how narrow this distribution is. It's not like one project has 1 bug per 1,000 lines of code and another project has 15. It's all really, really close together. And it supports this idea that you have a direct relationship between how much code you write and how many bugs you produce. And Node lets you write much less code. And it's as simple as that. Fewer lines of code, fewer bugs, less technical debt. And Node lets you work faster. Next slide. The other thing that happens with these complex languages and complex systems where you have massive XML configuration files, where you have 20 or 30-minute builds or hour-long builds, and where you have huge WAR files you have to deploy, is that to manage a team of 5 developers or 10 or 20 when you have a system like that requires huge amounts of ceremonial overhead. It requires things like Scrum. It requires things like Kanban. It requires software development methodologies because you just have to manage all this complexity. And there are some of my former colleagues sitting in the audience who will remember a time a couple of years ago where we were all working on a startup, and I had a habit of hacking on the system on Sunday evenings, late into the night, and then sleeping in on Monday mornings, and they would come in, and I would have broken the build. I was the CTO, by the way, so I was allowed to do this. I would have broken the build. So the whole team was down for the day because of my crazy ideas. And they actually had an intervention to stop me doing it. They nearly pulled my commit, but I kept it. The problem is, if you have this highly complex system, you have to manage for these issues because it's really easy to block everybody. Node solves this problem, and it solves it with, next slide. It solves it with the module system, which is just awesome. And I would say 50% of Node's power and Node's success is due to the module system. It's just absolutely brilliant. You can have all of these small little pieces put together. They all work together nicely. You can really, really separate out all the different pieces of the system into separate components. And I think it is important at this point to recognize that the deep open source nature of the Node module system is also part of the success of Node. I remember the first startup that I worked at, I had to have a huge argument with the CEO about intellectual property rights, because at the time I had a very unsuccessful open source project that was my baby. And the reality is the contract that I was going to sign, and Denise spoke about this stuff earlier, said, that's it, anything you think of, we own, which is hugely problematic. Luckily, times have advanced. For example, in nearForm, because we're dependent on Node and because Node needs the module system, there is nothing like that. As a company, we completely respect people's right to have their own open source. And I would strongly encourage every company that uses Node to think in those terms and go back and look at your employment contracts and those extremely harsh paragraphs where people say, we own everything you think of, because that is actually negative. It is negative for shareholder value. The Node module system gives us a software component system that is effective, much more effective than Java beans or assemblies or any of that sort of stuff. It really works, and you know it works. If you're using it in production, you know that it works really well. Next one, please. The other thing that Node does is looks after this problem of legacy integration. So in the early days, we were building systems, MVPs for startups. That was really fun and really easy, and we were connecting to Mongo, and there was no problems. Now, when you're building Node in big companies with big systems, you are connecting to all sorts of weird and wonderful external and internal systems, SOA-based systems, all that sort of stuff. That integration is always a choke point in any project. And the great thing about Node is it makes it really, really simple. And you've seen that in, you've seen what Walmart, for example, has done, where Node can be this wonderful, thin little proxy layer over everything. And it's really easy to start integrating Node and get it talking to everything else. This is just one of those boring things that you absolutely need and that Node does really, really well. And finally, we are moving away from a world where systems are built as these giant monoliths, where it's just one big code base and everything is deployed all at the same time. A node, we built our first Node systems that way, as big monoliths. But it turns out that Node kind of guides you and encourages you and steers you towards the next slide, please, towards this microservice approach, where you can run lots and lots of little node services, and there's low overhead, and it's really easy for them to talk to each other. Which means that you can do continuous delivery, which means that you can do digital transformation. So all of these barriers are addressed by different features, some by design and some by accident, of the Node ecosystem and the way that Node works. And I want to end with an example of the power of Node to deliver software in the real world. So one of our customers is a company called the London School of Marketing, and they do online learning. And they have, they're a company, they're a medium-sized company based in London, but they have big competitors, people like Coursera or Khan Academy. And they had a traditional IT system where they had a CMS delivering bits of content. But they were looking at changing their business because they knew they needed to move fast. And it's not so much that they had some grand vision about what they wanted to do. What they needed to be able to do was, week by week, respond to the needs of the educators and the students and their own customers that they were outsourcing to. They needed to be able to find out what the market needed and deliver it the next week, which is the exact definition of transforming your business into being a digital business, to be able to move as fast as Netflix. So we took them on as a customer, and it was an interesting project because we had to make a change in a 12-week period before the next term started. So, you know, we've often faced extreme deadlines in software engineering, and sometimes those deadlines can shift a little bit. This deadline was a kill the business deadline. If you didn't get live in time, students couldn't register and the term couldn't start. So I'm just gonna give you an example of the types of challenge, the types of project that Node can actually deliver on successfully. So would you take on this project? Right, so this project was a 12-week deadline, had to be done over the summer. It was 3 companies, ourselves and the customer, and another outsourcing company in the Ukraine. But the developers were actually spread over 6 countries, all the way from Jamaica to the Ukraine, I think, which was 10.5 time zone hours. There were 9 developers. 6 of them had never used Node before. 5 of them had never met, not even virtually. And 3 of them were new hires. And 3 of them spoke no English. So would you take this on? But it actually wasn't crazy, because we were going to use Node, we were going to use microservices, we were using GitHub and Slack and all the collaboration tools. We had full buy-in at the highest management level to make it happen. And when you have that converging together, and you know that Node is there and has your back, then you can be successful. Next slide. And that project worked, and that project was delivered. And that company has now moved into a mode where they are digitally transformed, because they are able to build things week by week and deploy things week by week, and they have achieved what they wanted to, which is continuous delivery. So Node breaks down these barriers and does them in, I think, 5 important ways. It makes people more productive. Why? Who knows? But the evidence is there. It definitely does. You write less code, fewer bugs, fewer technical debt, so you're delivering value sooner. You get practical code reuse because the module system is awesome. You can integrate with anything in the world, which you have to do in real systems. And of course, it works really well for microservices, which is another one of those new buzzwords, but which are also awesome. Node can deliver at the highest level for the biggest companies. So thank you very much, guys.